Alright, we're going to take a look at Chapter 4, Lesson 4, which is about parallel and perpendicular lines. So, previously we were working on writing equations in point-slope form and also slope-intercept form and standard form. So today we're going to be using what we know here to help us out with writing equations, and this time we're changing up the slopes. So here's some vocab words that you guys are going to need here. When we're talking about slope, here we go, I'm going to move myself for just a minute. When we're talking about our slope, when we say parallel lines, what we mean here is that the slopes are identical. These lines never cross and they never intersect, which means they have to have the exact same slope. So let's say you had 2x plus, 2/3 x plus 2. That means another line with the same slope. Remember, slope is right here in front of the x, so it'd be 2/3 x anything else. So I just wrote -1 on here as an example. These would be the equations for these two. So slopes identical. Perpendicular lines, on the other hand, their slopes are opposite and reciprocals. Two pieces to that. They're opposite and reciprocal. That makes sure that their lines intersect at a right angle. So this could be a right angle here, 90-degree angle. So let's say, for example, that one of these, the line is -4x plus 1, so that'd be this guy, -4x plus 1. So the opposite reciprocal, we're going to take -4. Think about that as saying -4 over 1, right? So the opposite reciprocal would be flip that and take away the negative. So that's going to be a positive 1 over 4x. Okay, so let's look at an example. This says write the slope-intercept form of an equation for a line that passes through this point and is parallel to this. So they're telling you, here's a point, they're telling you it's parallel, which means this is your slope. So do what you already know how to do with point-slope form, or you can use slope-intercept form, it doesn't really matter. You've got all kinds of tools in your algebra toolbox to figure out how to write an equation. So they're choosing to use point-slope form, so they're doing the slope with 1/2, and then the x and the y values, they're plugging those in. Pause right here if you want to take a look and go through the math. So the final answer they put in slope-intercept form, I think that's the easiest to read here. So that's y equals 1/2 x minus 4. You try this one. Pause right here, see what you can do. I'm going to go ahead and talk through it here. So this is saying here, when I work through it, we have a point, 2, 3, and a slope of 1/2. So I went ahead and put in the 1/2. This time I did it different. So instead of doing point-slope form, I just used slope-intercept form, and I figured we'll solve for b and then plug in our answer. So I used slope-intercept form, put in the slope, put in our 2 and our 3, worked through the math to solve for b. Once I got my b value, I plugged that into slope-intercept form because I already had slope. So I put in the intercept. That's our answer. Alright, how about this one? So this says the height of a trapezoid is the length of a segment that's perpendicular to the bases. So in a trapezoid, it tells us what our bases are, and it says, can EZ be used to measure the height of the trapezoid? I'm going to go with a no, because I don't think that this one looks perpendicular to this or this, but we'll see. So when they worked through this, they said, okay, well, first find the slope of RT, find the slope of AP, and see if this is perpendicular to it. So what they did is they found the slope of this to this, and then here to here, AP. So when they did that again, remember that you're doing, for slope, that's y2 minus y1 over x2 minus x1. Just a reminder. So that's how they plug these points, y2 minus y1, x2 minus x1. When they did that, these were the slopes for the bases, and this is the other slope. So it is not perpendicular. It is not an opposite reciprocal of this. Okay, so let's see what else we got here. This one. So this shows, this is one that you can try. It says, okay, so pause right here, see what you can do. I'm going to talk through it. It says the graph shows the diagonals of a rectangle, and we're supposed to figure out whether these diagonals are perpendicular. Might be. Looks close. If it's not, it looks close. So what I did here is slope y2 minus y1, x2 over x1, so I did JL first. So I did y2, so I plugged in the 1 minus y1, so that was this guy minus this guy. 1 minus 6, and on the bottom, x2 minus x1, so 6 minus 2 on bottom. So I got this. When I did km, y2 minus y1 over x2 minus x1, I got 5/4. They are opposites. One's negative and one's positive, but they are not reciprocals. So this one would have had to have been positive 4/5 instead of 5/4. So I said it is not perpendicular. Alright, this one says determine whether these are parallel or perpendicular. So the first step that they did here was they graphed them. You don't have to graph it if you don't want to. It's easier to see, but you don't have to. So even though they graphed it, they still worked through the math. Maybe they didn't. They are parallel because they have equal slopes. Okay. So what they did is they're looking at these, I guess they just looked at them on the graph. Okay. Well, you try this one. What I would suggest doing for this, this one's already in slope-intercept form, so you have the slope. I would put this one into slope-intercept form. This one actually already is as well. So I would compare the slopes for each of these, but first put this into slope-intercept form. Okay? So pause here, see what you can do. When I worked through it, I'll zoom in a bit so you can see what I did. When I worked through it, I took, well, the first one was easy because that was just already in slope-intercept form. The second one, it just says 3, so I was thinking about this as mx plus b, and it must have been 0x, which means our slope is 0. Okay? So it ends up just being y equals 3, but it really is in slope-intercept form with a slope of 0. The other one I had to do some work on. So this one I wanted to get y on a side by itself. So first thing I did, what did I do first? I subtracted x from both sides, so I ended up with negative 2y equals negative x minus 4. Once I did that, then I divided by 2 on both sides, and I ended up with y equals negative 1 over negative 2, right? So negative 1 over negative 2x, and then I had negative 4 over negative 2, which ended up being positive, so I put plus 4 over 2. And I simplified, that ends up being 1/2, and 4 over 2 ends up being 2. So now, the question was, are these parallel, perpendicular, whatever? This one, I don't know, it's not related to the other two. These two, I'm seeing negative 2 and positive 1 over 2. So if we imagine this as negative 2 over 1, and this is positive 1 over 2, these two are perpendicular. So the answer for this one ended up being, let me see if I can scroll. Guys, I can't scroll. Here we go. These two are perpendicular, but none of them are parallel. And this guy's on his own. No relation. Alright, how about this one? It says, write an equation in slope-intercept form for a line that passes through this point and is perpendicular to this. So, first thing we're going to have to do is put this into slope-intercept form so we can see the slope. This one got kind of messy here. So we had to, what do we do first? Subtract 7x from both sides. So that leaves us with this. Then divide by 2 on both sides. We end up with fractions. So if we're supposed to write an equation in slope-intercept form that passes through that point, so you have the slope, right? So now we have the slope, you have this point. Oh, and it's supposed to be perpendicular. Okay, so remember this, 7 over 2. So what they said is 7 over 2, the opposite reciprocal would be negative 2 over 7. So this is the slope that we're going to use. And we already had the point here, so we plug in that slope. We plug in 4 and negative 1 for x and y. And we simplify. And once we simplify all the way to slope-intercept form, it ends up looking like this. Negative 2 over 7x plus 1 over 7. Alright, you try. So this one's similar. It's asking for a graph or a line perpendicular to this one with this point. So pause right here, see what you can do. When I worked through it, I had to get it into slope-intercept form. So it ended up being negative 1/4 x. So my new slope would be positive 4 over 1, or just 4. And then I plugged in my points, so I plugged in -3 for x, so minus and negative ended up being plus 3. And then I plugged in -2 for y1, and it ended up being minus and -2, so it ended up being plus 2. And so my answer ended up having the slope of 4, and simplifies to 4x plus 10, which was b. Alright, so to summarize, parallel lines to non-vertical lines are parallel if they have the same slope. Perpendicular, I would say here, I would just say that it has to be opposite reciprocals for it. So here's your homework. Please let me know if you have any questions. Alright?